Okay, say hi to Andrew
Howdy.
and Lexi.
Howdy.
Lexi, I feel like I just saw you.
Yes, Andrew, Lexi was just here. She had to leave. So we did just see her. Okay, lesson 7.1. And this is area of a region between two curves. Andrew, I have the even answer sheet. You can come by my office tomorrow and pick it up.
What's today's date?
The 20th, 3/20. Okay. So, to start, before we go into some examples, hold on, Andrew. Brittany needs some paper.
I like you. She didn't know the paper spot.
Oh, okay.
Like, lay down on your phone.
Okay. So, for area between two curves, we need the following situations. F and g of x, so two functions, they have to be continuous on a open interval AB, and g of x has to be less than or equal to f of x. In this, they're not going to tell you which one is which. One of them has to be less than, okay, so that you can find the area between the two.
You mean like either f of x or g of x?
Yes, yeah, one of them. Because it's not necessarily going to say g of x is this, f of x is this.
So both are continuous? Just one?
Both of them have to be continuous.
Okay.
And one of them has to be lower than the other one, is what it's saying
Got it.
on the graph. And the area bounded by, wow, by f, g, and x equals a and x equals b is, so the equation for this is integral from a to b of f of x minus g of x dx. Okay? Let's do an example. Okay, we're just going to do a bunch of examples in here. And the first one's not in the book. So we are given y equals x squared plus 1 and y equals x. And x equals 0, x equals 1. So I'm basically finding the area enclosed by this system of equations. And I'm going to say that we are going to become very good at graphing, because you need to graph in order to know which function is on top of which. Do they intersect? Because if they intersect, then we sometimes have to split it into two regions. So if I were to graph this, the function y equals x goes through like this. X squared plus 1 is a parabola that what? That's shifted up 1.
They don't intersect.
They do not intersect. And I have the vertical line, x equals 0, and x equals 1. So my area that I'm looking to calculate is this area.
This feels familiar. Like, didn't we do something sort of like this?
No. In here?
Well, just like area between different functions and stuff.
You may have. You may have had a...
Always have.
Yeah. Okay, so based on this equation, my area is going to equal the integral. My x bounds are what? 0 to 1. And I need my, so up here, f of x is the function that's greater than g of x. Which one is my f of x? The parabola, the one up top. So it's going to be x squared plus 1 minus x dx.
We could say use,
We don't even need a u.
oh,
This is straight up, because I don't really need parentheses here. So I have integral 0 to 1 of x squared minus x plus 1 dx, if I wanted to make it fancy and nice. I don't need to do that. And that is integral of x squared, 1/3 x cubed,
minus 1/2 squared,
1/2 x squared,
plus x.
plus x from 0 to 1. What's nice is one of them was 0. So that goes on, I don't have to do anything with that. So now I have 1/3 minus 1/2 plus 1. For sake of time, I know you know how to find common denominator, this is 5/6.
And what's your answer?
That's your final answer.
No units?
No units. So there were no units given. If they were given, we would be able to do something with that. Okay, but, and you do not need to write units squared. So the area is 5/6. Now, before today, we would have had to use trapezoids. That's what you're thinking of. The area, we're thinking that an integral is the area underneath a curve. But now we're finding between two curves.
My question is, why do we learn the trapezoid rule and stuff like that if we have this?
That's before you learned calculus, right? Before you learned calculus, the reason of the trapezoid rule is to estimate it. And remember, we do not know how to integrate all functions. So we need another estimation method for functions we cannot find the exact. This is exact.
So calculus is that.
Yes.
Exactly.
Yeah. Okay. So now let's do an example where my functions intersect, but they don't tell me where they intersect. We need to figure that out. Okay? So let's do example, this is number 27. This is in the book. And they give us y equals x, y equals 2 minus x, and x equals 0. I need to find the area enclosed by this system. So if I were to graph, I have y equals x. That's easy. Well, hopefully all of these are easy. And this is the same as negative x plus 2, so I'm up 2, down 1/1, which is here. And the vertical line x equals 0, so my region is this triangle. Okay? In order, this is an easy one to figure out where the intersection point is. But if it was not super easy, I could use algebra and say x equals 2 minus x. Set my two functions equal to each other, because that's how I'm basically solving a system using substitution. Right? Does that make sense? Just to find this intersection point by saying x equals 2 minus x. So then I have 2x equals 2 or x equals 1. Because I need to find the x value for my bound. So area is equal to integral. What are my bounds now going to be?
0 and 1.
0 and 1. And I know it's 0 because I have this vertical line, x equals 0. Okay. Which one is the bigger function?
The one, well,
Or the higher function?
the one that's positive?
Nope. That's this one.
Oh, the one on top then.
Right? This one, this is my upper function. So if I were to draw a vertical line through this region, the upper function is the one that hits on top. Okay? So that's 2 minus x dx. Or area equals integral 0 to 2 of 2 minus 2x dx.
How'd you move it to 2?
Because my negative x minus x is negative 2x.
No, but how'd you move the bounds to?
I don't know. That should be a 1. Thank you. Thank you. Okay, so let's integrate. So integral of 2x minus
X squared.
evaluated from 0 to 1. So that's 2 times 1 minus 1 squared minus 0, because those terms would both cancel. So I have an area of 2. No, of 1. Dang,
Susan was one.
what is wrong with me?
Nothing is necklace.
No. Okay, and if I wanted to find the area of that triangle, I could do that, and it should be 1. It had better be. It is.
Wait, is it always going to be 0 to 1?
No. These two examples happen to have bound 0 to 1. It will not.
How do we know that?
How do we know it's 0 to 1? Because the left-hand side of this is at x equals 0. The right-hand side is at x equals 1. Does that make sense?
We also said equal to the other.
Well, we set that equal to find what that x value was.
And yes.
Okay? Okay. Let's do another one. This is example number 2. So same thing, we need to find intersection points. And they give us y1 equals x squared plus 2x plus 1, and y2 equals 2x plus 5. That's it. I need to graph these.
Oh,
Then you will determine the endpoints.
Yeah, they gave us nothing, so we need to determine both endpoints. So, but first of all, what does this graph look like? This top one. It's a parabola. How do I graph it? Ooh, this is a no calculator problem. This would easily be a no calculator problem on the AP test.
You just do
You what?
factor.
You could factor it. If it factors, that's the easiest way.
Okay.
Does this factor?
Yeah.
To
Yeah.
so this is a parabola shifted where? No.
Yeah, it's
Right, left.
To the left
Left,
one.
left one.
Okay, so I am here. And then I have 2x plus 5. So this is obviously going to intersect up above where I have my graph. And then my region is this.
Wait, how do you know where they intersect exactly?
We don't. And I should never use my graph to determine where that point is. I should use algebra.
Did you make them equal to each other?
I haven't yet.
Or I thought,
All I did is graph them. To find the
Yeah.
intersection points, that's a system of equations.
no, I know, but there's a point that you drew on the 2x plus 5 line that's above the,
It's plus 5, so it has to.
Why did I, these 2 points you mean?
that one, right there.
This one?
Yeah.
That's a slope, I came down to the left
Oh.
for the slope.
Okay.
Okay, so now to find the intersection points, I'm going to use substitution to solve for x. So I can do x plus 1. X plus 1 squared. No, it's going to be easier because I'm going to have to factor. X squared plus 2x plus 1 equals 2x plus 5. So the 2x's are gone. So I have x squared minus 4 equals 0.
Equals 32 down again.
Right?
But you-
Or I can factor it.
But when it
X plus 2, x minus 2 equals 0.
If you equal them to each other, then shouldn't you have a negative 5 too?
What?
What did you just do? You
Okay, so I canceled the 2 x's because if I subtracted that,
Yeah, but
then I subtracted 5.
but before that step, you equaled your y1 and your y2. Isn't that what you did?
Yes. Does that look like a minus sign?
That did look like a minus.
Okay.
Because I thought you brought it over.
No.
Okay.
Nope.
Okay.
Okay. So x equals plus or minus 2. I can find the y value, but I don't need it. because these are my bounds. This is the furthest left of my area. This is the furthest right of my area. So area is equal to integral from -2 to 2. Does that make sense how I'm getting the bounds? Okay. What is my upper function?
Your line.
My line. 2x plus 5 minus my parabola, which I'm just going to leave it like x squared plus 2x plus 1 dx. I can simplify it. So the 2x's cancel, and I get 5 minus x squared minus 1 dx, or area equals -2 to 2, negative x squared plus 4 dx. So integrating, negative x squared is
-1/3 x
plus 4x, evaluated from -2 to 2. Okay, so that's -1/3 times 8 plus 8 minus -1/3 times -8 minus 8. Okay, this becomes, okay, so I have -8/3 plus 8 minus 8/3 plus 8, or -16/3 plus 16, which comes out to be 32/3. If I found something that way. I thought you were going to ask a question.
I thought it was going to call.
Oh. Okay, are we good? So the majority of these you have to graph and find intersection points. Okay? The purpose of graphing is to visualize what the area region is.
It's also see which one is above the other.
Yes. Yes.
Is there any way you can do it without graphing, like just like looking at it? Anyway?
You can. It depends on what the functions are. But at this level, I think it's going to be worth graphing them. Okay? Because next lesson, we're going to take things like this. We're going to create regions like this and spin them.
Ooh, fun.
Okay? We're going to revolve them around the x-axis or the y-axis, and we're going to create volumes. Okay? We're going to create three-dimensional solids and find the volumes of them, which is fun.
It's fun, or is it like?
No, I really like it. I think it's fun.
So I wouldn't have to do with candy.
We're going to find the volume of candy.
Oh, that's crazy.
Yeah. Then we're going to find the volume of a banana,
That's what
like
I'm
an
gonna
actual banana that I'm going to bring in, and we're going to find the volume
do.
of
Like,
it.
eat a banana.
You can. Well, I'll bring in extras because you're not going to want to eat it after what we do today. Okay. Yeah.
That sounds uncomfortable.
Okay. What about curves that intersect at more than 2 points? And this is example number 5.
Did you tell me you're in 3 lessons today?
What?
Whoa.
No. There's 3 lessons in chapter 7.
Oh.
That's really like way more.
I was like, we're not going to have time for that, I don't think.
It's just a long, like, lesson, not like homework lesson.
Kind of, yeah. Okay, so number 5 gives us y equals 3 times x cubed minus x, and then y equals 0. Okay, I would say that this is going to be x cubed minus x is a polynomial. Could we graph it using the steps that we learned in pre-cal? Yes. Could we graph it using the steps we learned in calculus, finding rel min, rel max? Yes. They would not expect you to graph something like this by hand on the test without a calculator. This would be a calculator question. So go ahead and graph this on your calculator. And meanwhile, I'm going to attempt to graph this on the Inspire.
Ooh.
Ooh, it's so fancy. It's all touch
Wait
screen.
till you see, it's not touchscreen.
Oh.
You would think that they would.
It looks like it has a touch screen.
This is basically like, it basically be a computer.
But these are,
Oh, well.
you can't use it on any test.
You can
right?
use it on the AP test.
The Inspire?
Yes, yeah,
For real?
yes. What it can do to help you on the calculus, on the calculator section is not, it's the same as what it can do on your calculator.
So
Can this do way more than your calculator? Yes, but it wouldn't help you on the AP test.
Oh.
what is it that you can't use it on SATs and stuff?
Because it's basically a computer.
You can look up stuff?
Yeah. Well, not like connected to the internet, but it can,
Browser.
I don't know.
You're like, what?
I
the
still
hell
don't
would-
know yet about,
Okay.
this is so off. When I show you on Thursday what this calculator will do, it's gonna blow your mind. Yes, because it did mine, and I was so excited. Anyway, okay,
You do that?
Could you like program games and stuff on it?
you can do that on yours.
Mhm.
Well, no, like 3D games.
Yeah, yeah.
Like games on this thing? Probably not mine though, right? That's too old.
2D games though.
Yours, yes, it's an 84. Okay, did you graph it? You guys are done before me?
No,
Next.
not yet.
Like packing on the AP test.
Well, that's one way to
Fail.
get a
Make your
1.
teacher very disappointed.
Thank you.
You're welcome. I'm sorry.
Okay, so here I have a cubic, which we knew it would be a cubic, right? But I have something that looks like this, right? So if I were to sketch that, it is something like this, okay? So that's my first function. My second function that they gave me is a horizontal line at y equals 0. So my area that I'm calculating is this. Okay? If this were a true calculator question, you can find the intersection points easy, right? Go ahead and do that. Make sure you know how to do that on the calculator.
-1, 0.
And
1.
1. So x equals -1, 0, and 1.
There's no left. Mine,
Do you do that by looking at the table or just by looking at it? Like,
But you can use a 5 calc. You go to second trace and then 5 and then intersect.
wait. That Oh,
wait,
you don't have to
second
go.
trace.
If you do intersect, which is what you did, you need to have both functions in there. You need to have y equals 0 as well.
Mhm.
Yes, okay.
But you do second trace then what?
Yep. And
Intersect.
Then you go to 5. And then you scroll to where it does intersect, and then you click enter 3 times. Intersection.
Well, you have to.
You scroll near where it intersects. Yeah, it doesn't need to be on the intersection.
Oh, I got it. But then once I got my second curve or whatever, like didn't get my first curve.
Then you have to do it again.
Just have to keep doing it.
Mhm.
Okay, I don't know anything.
Okay. So how we're going to handle this, well, we know that these are symmetric. If we didn't, we would have to integrate twice and add them. And I'm going to do that at this point because just so we are in the habit of doing that, okay? But this is symmetric, so I could theoretically just find the intersection or the area of 1 and multiply by 2. So my area is going to be integral my bound, if I'm doing two different integrals, what's my bound of my area 1? This is
Negative
2.
0.
Negative 1 to 0 of what?
The negative side of that equation. I don't know.
Well, my upper function is this. My lower function is 0. So I'm going to have 3 times x cubed minus x. Well, I'm going to just distribute that 3 for easier. 3x cubed minus 3x minus 0 dx. I'm going to put that minus 0 in there so we know we're subtracting. And then plus integral 0 to 1, right? Because now I'm going from here. My upper function is now 0. My lower function is the cubic. So 0 minus 3x cubed plus 3x. I distributed the negative. Okay? So this integral becomes what? If I integrate 3x cubed, what does that become?
3 over 4 x to the 4th.
Minus
3 over
3
2
over 2
x.
Yep, evaluate from negative 1 to 0, plus. Now, over here, I have negative 3x cubed. That becomes what? That's right. Negative 3/4 x to the 4th. Then, plus, integral of this is
3 over 2 x squared.
evaluated from 0 to 1. Okay, so over here, this 0 term is gone. That's 0. So I have minus 3/4, negative 1 to the 4th is 1, minus 3/2. Plus, now my 0 is in the bottom, so that I don't have to subtract anything. So I have negative 3/4 plus 3/2. So negative 3/4 plus 3/2 minus 3/4 plus 3/2. Well, this is 6/4, 6/4. So I have minus 6/4 plus 12/4 equals 6 over 4, which is 3/2. Make sense? Okay, let's do something a little bit more fun. Because as fun as this is, we can make it a little bit more fun by turning things on its side.
Oh boy.
Already? There was nothing.
We're not revolving it. We're not moving anything yet. So this is horizontal representative rectangles. And this is example number 31. They give us two functions, f of y equals y squared, and g of y equals y plus 2. What? Okay. This is essentially x equals y squared. And this is x equals y plus 2. How do I graph x equals y squared? This is a no calculator question.
We know that x equals.
Square root of x.
Plus or minus square root x. Or if we remember back to conics, this is a parabola that opens on its side to the right. Okay? So x equals y squared, and this would be very common a common function for them to throw at you. Okay, so this is something you should be comfortable being able to graph. X equals y squared is a parabola that opens to the right. And another way, because we said y equals plus or minus square root x, which is, this is the positive square root x, this is the negative square root x. Okay, so that is another way to do it if you don't recognize that it's a parabola. But make sure that you remember it's plus or minus. Okay, over here, this is y equals x minus 2, if I solve for y. So now, minus 2, up 1 over 1. So this really connects over here, and this is my area. I'm not gonna shade it in, even though I started already. Now, here is a problem with this function. The problem is this point here. Okay? If I were to subtract this function minus this function, I have this line right here that is an issue. Because of how this scoots out over to the side, I would lose, there's no function at the bottom of it, right? I would lose some of my area. So I'd have to do one area and two areas. Or I can imagine that this is horizontal and do horizontal rectangles per se. We're going to use calculus, we're going to use intervals, but we're going to do it horizontally instead of vertically. Okay? All right?
So we're missing from the area because of the bounds,
Yes.
and we have bounds.
Well, we'd have to split it into two areas.
Yeah, but they gave us the bounds, right?
No, they didn't. We'd have to find we still have to find intersection points.
So then how do we already know that we split it?
Because of how this part of the area juts out. And it's underneath itself. Does that make sense? That one function is underneath itself.
Oh, I see.
Okay.
I'm sorry.
Do you understand how we graphed the two functions? Okay.
I was writing on the other stuff, so I didn't see it.
Okay. This is a parabola on its side. X equals y squared. Or y equals plus or minus square root x.
Right.
Parabola on its side. This I can solve as y equals x minus 2. Graph the line. They intersect. Here and here. Okay? The issue that I have is on the left of this line that I divided right here, this function comes down below itself. So using vertical area underneath the curve is an issue. This is not a function by terms, not a function in terms of y, because it doesn't pass a vertical line test. Does that make sense? Okay. So, what we're going to do, what time is it? Everybody stand up.
Wait, for what's the line?
Not just you. Everybody stand up. Walk around the room or do something. Andrew, if you're falling asleep too because it's the second day back, get up and stand up. Lexi, stretch your legs. I understand. You were not the only one whose eyes were taking a break.
You see me?
Yes.
I was trying to.
You were trying so hard to make it so that I wouldn't see it. I know, you were trying to stay awake. I get it. Okay? This is a long class. Do something to wake yourselves up.
I was fine until like a few minutes ago. And then
Yeah, me too, actually.
I know. Well, because the door's closed in here now, it's starting to get warmer in here.
May I get a sip of water?
Go get a sip of water, and when you come back, leave the door open. Unless it gets done.
Doodling, it kind of helps me stay awake. So I was like, I kind of had to mention it.
Wait, so my teaching doesn't keep you awake? What?
You should have seen
The calculus itself doesn't keep you awake? I get it.
It kind of confused
I get
me,
it.
so then
Shaking my
brain
leg.
shuts off.
And then I was like,
Oh, yeah. Yeah,
I was
Lexi was not here to hit you, to keep you awake. No, I know, I'm just joking.
I mean, she probably thinks about hitting me.
We're taking a stretch break
Hey, Mr. Don.
to keep us awake. Yeah, stretch.
Oh my gosh.
Well, all right, bye, Mr. Don.
The reason I was confused by the graph is what are those like horizontal
The
lines?
horizontal line, we're going to integrate horizontally. And this is like the rectangle. Remember when we approximated an integral with rectangles?
But-
We're going to do it horizontally.
Oh, so we like moved it?
We're going to integrate on its
Can I
side.
just split it into two? That's so much more fun.
We're going to do it both ways.
I'd rather split
Okay,
it
what
into
is,
two.
what is that vertical line?
The vertical line is the line that divides where, so on this side I have a function on top of one. This one, this function itself comes down underneath itself.
Could use a little of this. This yours?
Yes.
So,
Put it on my fingers.
is the line?
Andrew and Lexi, Brittany just took my bottle of water and is going to pour some of it in her hand and throw it in her face. I first thought she was going to drink from it. And I was going to say, no.
Well, this is a different story.
We wish you could have seen that.
Okay. I'm ready now.
It looks sweaty.
A tough day. It's a bad day for y'all to miss. Brittany looks sweaty now. Can I have my water back?
There you go.
Okay, back to integrating horizontally.
So, is that line from like the point where they intersect up?
Yes.
Oh, okay. That's the thing I missed. And I was so
Okay. Okay, so I need to find, we're going to be integrating horizontally, which is I need to find this intersection and this intersection. Because my bounds are now going to be, this is my lower bound, and this is my upper bound. If I imagined turning it on its side. Okay? So I need to set them equal to each other. And my lower bound is going to be, and upper bound are going to be y values, not x values. So to set them equal to each other, I have x equals y squared and x equals y plus 2. I'm going to say y squared equals y plus 2. Or y squared minus y minus 2 equals 0. That is y minus 2, y plus 1 equals 0. Or y equals 2, negative 1. So area equals integral from negative 1 to 2 of my upper bound. Now again, turn my paper. My region is here. What is my upper function?
Your y plus
Yes, the line. So that's y plus 2. Minus my lower function is the parabola, which is y squared. And now, instead of dx, because we've normally been integrating in terms of x, now I only have y's, I'm going to write dy. Okay? So my area is going to be, now we integrate, integral of y,
1/2 y squared.
1/2 y squared, plus
2y.
2y, minus
1/3 y.
y cubed, evaluated from negative 1 to 2. I'm going to spare you the fractions. Area equals 9/2.
Graphing and fractions. my gosh.
I
Yes.
actually love fractions a lot.
Yeah, well,
Wow.
you like fractions?
I love fractions. Fractions are fun.
Okay.
It's just when your answer is a fraction, though.
Yeah. So let me show you the advantage
I'm doing them like
of doing it horizontally. Okay? I'm going to, on the next piece of paper, I'm going to redraw this graph. So we have did it again. Okay. So I have this line where I have a function on top of another function. This, I'm going to say, is region 1. Because this is not a function here. there's no bottom function. I'm not finding the area between two curves. I need to find the area underneath the curve. And I need two functions here. So here I'm going to split this into 1 and 2. These are symmetric, right? So I'm going to say that this is area 2 and this is area 3. Area of 2 plus 3 is equal to 2 times area 2 because they're symmetric. Because these are symmetric, the area of this region, the 2 and the 3 together, is twice the area of 2. Okay? So my total area is going to be the integral, and we did not find the x values. I can say that this is 0, this is 1, and this is 4. Okay? This is 4, 2. This is 1, negative 1. And 0, 0. Yeah, sorry. Okay.
Well, you have to find those points first. Right?
Yes. Okay, but we know how to do that, right?
Yeah.
Okay.
I forgot momentarily.
Okay. So if I needed to find this point, from how I did this previously, when I set them equal to each other, I found that that's not the right page, this one, where y equals 2 and negative 1, I could come here and throw that in and find the x values.
Oh, okay.
Does that make sense?
That makes sense.
Okay. So here I'm going to say this is integral from 0 to 1 of 2 times this area, which we just said this part of the curve is positive square root x. This part is negative square root x. So 2 square root x dx plus integral 1 to 4. Now I can do the area between two curves, which this is my square root x minus my function in terms of y is x minus 2 for my linear. I'm going to do x minus 2 dx.
What's an area equals 2 equals 2 times?
It's the area of 2.
What do you put? Which one do you put?
I don't want to do all this work. There's a lot of work. I had to first, okay, what is this function in terms of x? Which isn't that hard. But realizing that I have to double it, and I have to do 2 integrals.
Yeah. Okay, that's fair.
Okay?
The first way, all you're doing is just looking at it this way.
Yes. You just flip it. Or you just
Okay,
kind of basically
that
flip
is
it. It is easier. I know it feels foreign, but I promise you when you do a few, it's going to be easier.
Right.
And if I were to do this out, I'm going to get area equals 9/2. It's going to be the exact same. Okay? One last example, and we're going to get through all the notes for today. Okay.
I'm sorry. Y'all may not be able to see Ms. Nichols on the screen, but you'll be able to see her.
Oh, yes, my nails.
Do you know like?
Yeah.
I always wait.
She got it.
Okay. So this is an example not in the book. X equals 1 minus y squared, and x equals y squared minus 1. Ooh, more parabolas on their sides. Yes. Okay? So let's remember how to graph this. Okay? Let's do this one. Let's do this one first. This y squared minus 1. A way to remember this. If I wanted to, in my mind, think y equals x squared minus 1, I can turn my paper. And if I just turned it, right, this is still my x, this is still my y. If I turn this, x squared minus 1 is a parabola that what? How is it shifted?
X squared minus one.
Down 1. So I can come here and do a parabola this way, opening up after I turned it.
Wait, why is it down there? Oh,
Because
I read
y
it.
squared minus 1.
Okay, yes,
I'm
sorry, I
doing
was
the
looking at
second
wrong
one.
thing.
Okay?
And the first one is going to be reflected.
It's going to be reflected. It's going to open down, up 1. So it's going to open down, up 1. Okay? So my region is this. And because my functions are, these are not functions straight up because they don't pass the vertical line test.
Yeah.
So I would have to do some manipulation to figure out how to solve this in the vertical. Okay, but I'm going to do horizontal. And that means I need to solve for my my y values. So I'm going to, by substitution, I'm going to set these equal to 1 minus y squared equals y squared minus 1. And I get 2y squared equals 2, or y squared equals 1, y equals plus or minus 1. So my area is going to be negative 1 to 1. Now, which one is on top? Turn my page. The one that upside down with a negative y squared. So I have 1 minus y squared minus y squared minus 1 dy. And I can clean this up first before I integrate. Or 1 plus 1 is 2 minus 2y squared dy.
That's 2y minus 2y squared.
Okay, and for sake of time, that equals 8/3. So this, now we've done one in the horizontal. As long as you are comfortable turning the page, seeing which one's on top, realizing your bounds are y values where they intersect, not x values, you'll be okay. All right? That is it for notes. Yay! Exactly, the bell just rang. So let me stop this. Bye, guys. I will post this online. All right.